right brothers channel. So today we are going to discuss a mathematical example for principal component analysis. Before getting into this, I suggest you to watch my previous video for a clear view of what is principal component. So in the earlier video, I have told you how to assign a priority to a principal component. Now let us see with a clear mathematical example. So I have taken a data set consisting of two attributes x and y. A random data set consisting of values 0, 1, 4, etc. and so on. So now with this data set, first of all you are going to calculate the mean. X bar as 4 and y bar as 5. I think everyone is aware of mean formula, sum of observations by number of observations. So with the help of this mean, we are going to calculate the covariance matrix. So what is the formula for the covariance matrix? Covariance of x comma x, covariance of x comma y comma x and y comma y. So the formula for this covariance is covariance of x comma y is equals to sigma I equal to 1 to n, where n will be the number of observations in the data set and xi means the ith observation minus x bar will be the mean into yi minus y bar by n minus 1. Let us solve this formula with our data set. Now substitute x comma x in the place of x comma y. What you will be getting for the first observation, that is I equal to 1, which will be xi will be 0, so you will substitute here, and minus x bar which will be 4, whereas in the place of yi and y bar you are going to take the similar x because we are calculating the covariance of x comma x. So now the same thing, 0 minus 4 again. So now where n is equals to 5, as we have taken 5 observations, what will be 5 minus 1? It will be 4. Now 0 minus 4 into 0 minus 4 by 4, which will be 16 by 4, which is equal to 4. Similarly, you are going to calculate all the observations, and soon after you have calculated, as there is sigma here, you are going to sum all these observations and the value will be 13.5. Similarly, you are going to substitute these values into the formula and you will be getting for x comma y, it is 7.5. The covariance of x comma y will be always equal to the covariance of y comma x. So here also it will be 7.5. Next, you will calculate the covariance of y comma y, which is 6.5. Now substitute these values and form a matrix C, which will be 13.5, 7.5, 7.5 and 6.5. So by using this covariance matrix, we are going to find the eigenvalues and eigenvectors. So based upon those eigenvectors, you are going to determine the highest priority principal component. Now, by using this covariance matrix, we are going to find out the eigenvalues, which is given by C minus lambda I, where I is the identity matrix of 2 by 2, since this covariance matrix is also of size 2 by 2. Now by making determinant equal to 0, we are going to find out the eigenvalues lambda 1 and lambda 2. And by substituting C minus lambda I is equals to 0, we are going to get lambda 1 value as 18.275 and lambda 2 value as 1.725. So by using these eigenvalues, we are going to find out the eigenvectors. So with the help of this covariance matrix and these eigenvalues, we are going to find out the eigenvectors using this formula, where C into x1 y1 is equals to lambda 1 into x1 y1. Now soon after solving this, we will be getting these x1 is equals to 1.57 times of y1. Similarly, by replacing this lambda 1 with lambda 2, we are going to get these two equations. On solving these two equations, we will be getting minus 157 times of x2 is equals to y2. So these two will be considered as the eigenvectors, which will be x1 minus 1.57 y1 equal to 0 and 1.57 x2 minus y2 is equals to 0. So these two will be the eigenvectors. So now you may have a question that which eigenvector should be considered as the intelligent model. As you are able to see that lambda 1 is greater than lambda 2, we are going to give the highest priority to this lambda 1. Now the model will be x1 minus 1.57 y1 equal to 0. So for this data, we have obtained these two eigenvectors. So in order to find out the best fit model, you are going to plot this best vector, that is the vector with the highest eigenvalue on the graph. For example, let us assume that this line, some random line which satisfies this equation, will be that vector. So now we can say that this line is the best fit model for this data, because as I have told you earlier, the vector which is having the highest eigenvalue will be having the highest priority. So this will be 1, and let us assume that this is also 1. Now you are going to plot the second vector 2. So this will be the second best model for this data. So as there are only two attributes, you will be having only two components. Now this lambda 1 and this lambda 2 will be acting as your principal components. That means that these two are the line equations that have been obtained from your principal components. As I have told you in the earlier video, the principal component with the highest priority will be acting as your best model. That means for this data, this line 1 will be acting as the best model compared to this 2 as well as underfitting or overfitting models that have been obtained. For further queries, I request you to mention them in the comments below. Thank you.